Class is over still. Oh my gosh, what do we got going on here? Good to see you here. Meath, Jackson, Kevin, Peyton, and Kevin again. I have some 474 stuff to ask you on Discord later. Oh, definitely ask away, Kevin. Great work. We're going to start up here in a second with some 320. So I have to leave, but I was wondering if you go over question 5. So we got question 5. Por favor y gracias. Muy bien. Yo lo tengo. Hay mucho questions. I-320. Este dia hoy. Ava, great to see you here. Let us know what questions you have. We're about to do some 320 to start, and then we'll be doing some more, probably 201. It's all about the questions people have. Bring those questions. We'll bring the work, and we will practice. That's what we're here to do, is to practice and learn how to do things. Hey, Bracy, great to see you here. Let us know whatever you're working on. We got an assignment due tomorrow for 320. We did some 474 earlier. So we're loading up 320 right here. Okay, let's take a look at a question from Chapter 3 quiz. Just how accurate are the weather forecasts? Oh, the rain, no rain, right? So let's put that on the list. Stat 201, Chapter 3 quiz. Rain, no rain. That is a famous question. We love that one, Ava. Good question. We'll be doing that here in about probably 15, 20 minutes. Stay tuned. More questions to come here on these office hours. Let's do it. Okay, so we've got assignment 2, question 2, and we'll talk over the theory behind this. Here we go. Let's check it out. Okay, so question number 2 is right here, and we're looking at the following. Translate a for loop into the underlying sequence of commands and vice versa is good practice. To a second. I am back. Let's go. We're back right here. You bet. How are we going over the 201 quiz for the previous office? We could, Rhea. Let me know which one you want to work on. We'll talk about it. Let me know which one. Just say, hey, let's work on it, and we will. Okay, I can stay at yeah, Ava, anytime. I put it on the list, Ava, so it's on there. Okay, so identify the vector. Okay, what is a vector? Let's look at this right here. Don't do this work I am doing. This is not part of the problem. A lot of times people will copy down exactly what I write down. So don't, oh, Mewbot's finally awake? I don't think I re-woke him up, but he's here. Let me re-wake him up. And then we'll throw out some points. Okay. I think he woke up and figured out we were streaming again. Okay. There we go. Sometimes he destroys the universe. Okay. So when we do a for loop has 3 components. A for loop is a variable, a vector, and a skeleton. It is a one-dimensional. The vector is one-dimensional. So when you think about what the vector is, remember I'm doing not part of the problem right now. Identify the vector here. So identify the vector in this. Just identify the vector to start of this. This is a much simpler problem right here, just to understand the terminology. Look at lines 77 through 79 and identify the vector. I just want you to identify the vector. 1 to 10, great job, John, right there. It's 1 to 10. So this is the vector it's going through when it runs the loop. Identify the variable, the placeholder, which is the variable right here. Placeholder is just another name for the variable. For right down here, identify the variable that it's using. So identify the variable that it's using. And then I want you to look at this some more from. I'm not going to solve this exactly. I'm going to show you the components of it, and then I want you to put it together. So identify the variable. It's using I, right? I is the variable right here. So we'd say, okay, if you look at this, the vector is 1 to 10, and then the variable, which is the placeholder, is I, and then what is the skeleton? If you had to identify the skeleton right there, what is the skeleton? What is the skeleton? Print I. That's the code that just repeats every time it runs. So that's the vector it goes through is 1 to 10, which is in this position. The placeholder is I. That's the thing that changes. Great job, Meath, right there, and John. And then the skeleton is the code that it runs every time inside the loop. The skeleton never changes. So it's going to print I, print I, print I. So if we look at how it works for our loop up here, if you look at the following code, we need to take right here and turn this into a skeleton. So I'm going to do one of the hardest parts of this problem is taking this code right here and turning it into a skeleton to start. So to turn it into a skeleton, I need to input what's into it. To turn it into a skeleton, I'm going to have to input what's into it. Probably might be easiest. Well, that sort of thing right there. Put an I into it, right? And the I is just a placeholder. It could be anything. We call it number or whatever. You can't use reserved things, but we could call it number. I'm going to go right here and say I is equal to 4. If I is equal to 4, then what will this become right here? If I is equal to 4, what will that become? And so think about what that will be. If I is equal to 4, what does that become? If I is equal to 4, what will that become? Well, it is 4. It'll be I plus 1. If I is equal to 4, what is this? So this is 4 right now, and I is 4. It'll be just I, right? It'll be just I. So what will 5 become? What will 5 become? What will 5 be? So I is 4 right now. I plus 1, right? Because then we can test this because we could highlight it and we see that that's 5. Now, let's store our X right there. Now, what is 2? If I is 4, then what is 2? Great job, Bracy, right there. If I is 4, then what is 2? Now, be careful, be careful, be careful. If I is 4, what is 3? But be careful, I'm purposely asking you a trick question. Think about why it's a trick question and look right here. So if I is 4, what is 3? Be careful. It's a constant. The reason you might say, well, that's I minus 1, but this is a constant. It doesn't change as the loop runs. Does that make sense why this would not change right here? The reason these other ones have to be referenced as I is because they change as the loop runs. Because the relationship that this always has right here is that if we're doing I is equal to 4, then this would be 4, 5, 3. Wait, 2. That's 2 right there. 4 minus 2 is 2. And then if we change this to 5 right here, and we'll watch, what are the values of numbers used inside of these I things right here? If I is equal to 5, what is the values of numbers being used right here? If I is equal to 5, what are the values of things being used? Like, tell me blank, blank, blank. I mean, I know it's 5, 5, 5, but this would solve for this. This would solve for this. This would solve for this. What are the values being used if I is equal to 5? It is I is 5, 5, 5, but what are the values being used right here? There, you can cheat and look a little bit lower. What are the values being used for this blank, this blank, this blank? If I is equal to 5, then the values being used inside of here, here, and here when you solve them would be what? And you can cheat by looking a little bit lower. You can also solve 5, 6, 3, because 5 plus 1 is 6, 5 minus 2 is 3. And take a look, if I is equal to 6, now do it really quickly. If I is equal to 6, then the blanks would be equal to what? I mean, you can do the math, or you can cheat and look down below. If I is equal to 6, which this code will do, then what are the values inside the blanks going to be equal to if I is equal to 6? If I is equal to 6, then the values in the blank, and 100 points meets, great job on all this practice right here. The values in the blanks of I is equal to 6 are going to be blank, blank, blank. Or the values where I is being used, 6, 7, 4, which is what we're doing, because it'd be 6, 6 plus 1, 7, and the 6 minus 2 is 4. So it's going to solve this all out for us. So that's why we need to identify for this problem. First off, we've made a skeleton right here. Do you see the skeleton? This is the skeleton, the code that we can run that doesn't change. A skeleton is a code that runs that doesn't change. It goes inside your for loop. We're not going to change that. We're just going to change the value in the what right now. What will change? Now, we're not changing the skeleton. We're changing the value inside of the what, which is inside the skeleton. We're going to change the value inside of the I, which is the placeholder, right? So I is the placeholder. And then right here, we have one last thing right here we need to identify is the what. And it wouldn't be called that. It'd be called this. That's the what right there. What is that right there, which is our goal of this? This is the what. Now, this is not the answer. I'm kind of showing the components. Brian didn't fully solve this. Well, you need to figure out how to run it with making a skeleton. So you don't want to usually jump, like if you're first writing for loops, you don't want to just try writing it all. I mean, you could probably do it if you try, but usually you want to identify what's your vector you're going through, what's your variable that's going to be the placeholder, and what does your skeleton look like, the code that repeats. So a lot of times you write a few instances of it to get it going. So what is this last thing right here called? Because these are the numbers I'm going to go through as I run this. I'm going to go 4, then I'm going to go 5, I'm going to go 6. What is this thing called right here? If these are the values I'm going to go through, that is called the what? That's the vector. So if you take a look at what we figured out right here, we had to identify the vector. We had to identify, but this is not done. We now need to, I'm not going to show you the answer, but you need to put it together into a working for loop. Does that make sense? You need to put this together into a working for loop, but I've showed you the components of it. So now, like, not solved. Because it needs to actually run. We loop 4 through 100, correct. So do we overwrite the fourth position that has 3? Oh, yeah, I guess you do. Yeah, you do. Good answer, Meath, right there. You would overwrite it. You will overwrite it. That is true. You will overwrite the fourth position because you're looping from 4 to 100, so you will overwrite it. Good answer, Meath, right there. It already has something in the fourth position, so the first time it will overwrite to the fourth position. It does say go 4 to 100. Yep. You will overwrite it. Good answers, Meath, right there. But this is not solved. You're supposed to, like, write a loop. Write your loop so that it works. Your vector, placeholder, and skeleton. But I've identified a lot of the components. You don't have to initialize I. No, because you can, like, this is just another, like, you could write for Brian. You don't have to initialize Brian. 1 to 10, print Brian. So it'll initialize Brian for you. It'll make the Brian thing, and it'll store into Brian 1, creating Brian. So you see Brian has 10 as integer format. That's what the L means right there. But John, great questions right there. It'll initialize that for you. Now, these aren't the answers, but you literally have the components. Meath and John, does it make sense what you need right here? How you have the vector, you have the placeholder, you have the skeleton, and then you're making it so that you have a for loop with your vector, placeholder, and skeleton. I'm kind of trying to point to the answer here because I've given you the components. Great job right there, Meath. And please, if you're watching this, let us know. Ask questions on Discord. Once you start to get this, it's like a ball rolling down the hill. It starts to go where we do now. I was one line off. I had it, and I had an added parentheses. No worry, yay, John, great job right there. It's when you make a little error, it snowballs. Okay, so now we got question number 3 right here. We'll be doing some more 201 here in a moment. Question number 3. Okay, let's take a look at question 3. Question number 3 has us using Morty, Jolly, Thump, Magic Bunny. And so what we need to do is we need to write 10 lines of code. And so once again, Brian is showing you the theory, not the answer. So this is not the answer. It's the theory behind how it works. I want you to take a look at the following for loop that does the following. This for loop right here, we use a very simple idea of what's going on. Good to see you, Muskan. We're going to have here Bunny, and we're going to have here 1 through 10. I'm going to say print Bunny. Okay. So I want you to tell me, and let's even do it smaller. You ready? On this line of code right here, what does the for loop do? The for loop is using the placeholder Bunny that goes through the elements 1 through 2, and then it prints Bunny every time. So the for loop right here will do what the first time it runs line 126. This is the theory to the answer, which solves the answer. The for loop will do what on line 126 when it runs the first time? What does this for loop do? Assign 1 to Bunny, vice versa. The first thing it does right there, and John, great answer, it's going to say Bunny is 1. So it assigns 1 to Bunny. Bunny to 1. 1 to Bunny, rather. But then it will it will print 1, but it's not necessarily, it's not doing this. It's not doing print 1. It's doing what? It's not printing 1. Like, it is going to print 1, but it's not printing 1. It's printing 1 because why? So this is why the skeleton never changes. Hint, the skeleton never changes. Whatever the skeleton is the skeleton. It stays the same every time. It's going to print 1, but it's not printing 1. Correct, John. So what's it going to do? You're right. It's not going to print 1, though. I mean, it will print 1, but it doesn't do it by printing 1. Does that make sense? You will see 1 printed to the screen, but not because it ran print 1. It's going to run print what? It prints bunny, which has the value of 1. So it's going to print, oh, we didn't store it. There we go. It prints 1 because bunny currently has 1 stored to it. Then it's going to what back up to the start. It's going to what? Use the word, 4-letter word. It's going to what back up to the start. So it ran through here. It went boop, 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 boop. It did this line, and then it goes back up to the start. It loops back around, and it says, now what? I think people are seeing it because you can actually just copy paste what it's doing. It just reassigns bunny to 2. And so now bunny is assigned to 2, and it prints bunny again. So now bunny has a different value because the placeholder has changed. So it's going to print 2 because bunny is 2. So it's still just printing bunny. So anytime this loop runs, we can make it run for more times, like 20 times. We just kind of do a dot, dot, dot here to explain it theoretically, because it's just going to keep looping through and changing what the value of bunny is every time it does it. So if you think about your code up here, because this basically shows the answer, we're not going to put it fully. I mean, we can put little parts and people can figure it out. Like put little hints in here, little hints. Does it make sense what this is going to do when it first runs? When this loop first runs right here, what does it do? When this loop first runs, what does it do? When this loop first runs, what does it do? When this loop first runs right here, what does it do? So this creates a blank vector to store the object y into. That's not the loop, though. The loop is right in here. Meet right there. I'll allow that. That's a good answer, because I was asking, basically, I'm asking about this one now. It's going to assign the first element of the vector into the placeholder, which Meath has in the chat. So, am I congested today? No. So now when you look at this right here, it's going to then run the code inside the skeleton. I want you to look at this. Let's write some crazy thing right here. Big loop. And in a now this looks a little bit crazier right here. We're doing another example. Cool. It's a mess. Cool. Yeah. Okay. Don't worry about the output of this. I just want you to think about this for a moment here. You ready? Print. And then did not cat? Oh, cat's at the end. Oh, the cat's at the end of it. That's confusing that a cat's at the end. The cat is a print to the screen. Oh, no, let's just paste it then. Let's not cat it. Let's just paste it. Cool. Oh, because it's not showing that. Let's say paste length. Interesting. Huh. Okay, let's do this. Cat. Awesome. Exactly what I wanted. Can you go over Mosaic plots again? Yeah, Taylor, which one are you working on? Homework 3? Mention a problem on homework 3. We'll take a look at that. So I want us to think about what this loop does right here. You ready? What does this loop do? The first thing this loop does is what? So Meath, we got the hang of this right here. What's the first thing this loop does? The first thing this loop does, we've got the placeholder name right here. We've got the vector of elements it goes through. So I want you to see the theory of how this is solved. Boom. Big loop gets A assigned to it first thing. So that's what the loop's going to do first. Is it's going to assign the first element of the vector to the exactly right there. John got it right there. Excellent. And then I could what to talk about theoretically what it's to do, because this doesn't change. So what are you going to see me do right here to show? And these are hints for solving your question. The skeleton never changes. The skeleton never changes. Mr. Skeletor down here, never going to change. He's going to be the same every time, doing that same loop right there as he loops through. Can you go over the quiz for tonight? Which quiz, Taylor? Let me know which quiz questions. Definitely. And so what am I going to do to this code? Because it never changes. This is hints for your question on how to solve it theoretically, because the skeleton doesn't change. The placeholder inside the skeleton does change though. So what am I going to do right here to get my answer for what's going on when this loop runs is I'm going to what? Here's the theory for how this is solved, because do you notice how the skeleton, do you notice right there, and we can make this smaller to display it. It's the same code every time because the skeleton never changes. It's just what we're doing as the placeholder changes. So this right here, I made the loop a little shorter so I didn't have to run it, but that is what that loop is doing for us. Does that make sense maybe to see it? That it's going to assign A to big loop, run the code inside the skeleton, assign B to big loop, run the code inside the skeleton, assign C to big loop, run the code inside the skeleton. So the skeleton is always the exact same code every time. It doesn't change. So whatever inside the skeleton right here, you don't change it. That's like the number one thing people do wrong in this question is they're like trying to change what that value is right there. And no, the skeleton doesn't change. Whatever's inside the skeleton stays the same. The placeholder is assigned the values through the vector. So it just says first element stores into this, run the skeleton. Second element store into this, run the skeleton. Third element store into this, run the skeleton. Question 4, 3.5, fish prostate cancer revisited. Ooh, let's take a look at that. So that's on the quiz or homework. Taylor says chapter 3 quiz. Okay. Stat 201. We got Stat 201 coming up here in just a moment. Chapter 3 quiz, homework. Fish and prostate cancer. Ooh, interesting stuff. Thank you, Taylor, right there. 100 points. One more 320 question, then we're hopping over to some 201. Thank you, 201, for hanging out here and doing some work. We're going to look at number 5 right here. Remember, I'm doing similar but different works. You're welcome, John. We're going to do one more. Maybe so nice, those goats right there. Load in the tips data set right here, and then we need to write a for loop that finds the median for each day. Yeah, it takes a lot of practice, Meath, right here, to like understand and then just get it down. And then when you see it, you're like, oh, that's how it works right there. So we're going to find the median tip by each day. I'm going to do a little bit totally different problem right here. This is different but similar. Totally different but similar. Totally different but similar problem to talk about the theory behind how to do this. So what you first want to write, step 1, write one instance of your loop working. So we go down the theory down here below. So I'm basically doing the same work, but I'm doing it for a different problem. My problem is going to say, find the average MPG for different cylinders of cars in the MT cars data frame. So this is a similar but different work. Bracy asked question 3, part 3 with the graphs for females and males on the L. Yeah, okay. So question 3, part 3. Is that quiz? It's the quiz, is it? Oh, with the quiz question, let me know if it's a quiz question. Let me know the start of it. Just tell me the start of the question. I'll find it, Bracy, right there. Because quiz questions are different. Like your quiz question 3 will be different than mine. So start the question with like in a research study or something like that. If you copy paste the start of it, like the first 4 words of it, I can usually find it because your quiz questions will be different than my quiz questions. Thank you so much for asking, Bracy, and we'll make sure we put that one on the list, and we'll be doing it here soon. So the first thing I want to do right here is if I have the MT cars data frame, we'll make it appear over here. I want to find the average miles per gallon per cylinder. Or we could even do the median like this one says. So I'd probably want to take a what of the different cylinders of cars. Think of a 6-letter word where I want to take a smaller version of it. I want to take a what of the cylinders of cars. Like I only want the 4-cylinder cars. I only want the 6-cylinder cars. I only want the 8, a subset, right? So we're going to have to subset this right here. Now we could look at the cylinders of the car by putting in here unique. And with the unique MT cars cylinders, these are the unique values of cylinders. We could also sort it right here to get a sorted version of it. So does that make sense? These are the unique students and introductory. Thank you so much. Let's do that here in just a little bit. You got it, Bracy. Students and introductory. I'm going to copy paste this. So those are the unique values of cylinders right there. So we know there are 4-cylinder cars, 6-cylinder cars, and 8-cylinder cars. So with this, we are now going to start by looking at 4-cylinder cars. So let's go right here and say sub store into subset and take the MT cars data frame and do what? how would I get, and here I'll show you what cylinders looks like, how would I get just the 6-cylinder cars? I need a condition that, or 4-cylinder cars. We'll start with 4 cylinders. How would I get just the 4-cylinder cars to start? How would I get just the 4-cylinder cars? How would I get, so I'd say subset my MT cars data frame and I only want 4-cylinder cars. How would I do that right here? How would I adjust my 4-cylinder cars? So you got a hint right there on what the variable is called inside the data frame. How would I say give me only logically equal to 4 cylinders? You could do that. Since you're inside of this, you can just write right here. Great answers, Meath and John right there. It does work if you reference it, but you can just call CYL. It'll work either which way, as Rock always says. It doesn't matter. And we can see right here, visually speaking, that if you did it this way or that way, you're going to get the same thing. We could call it sub 2 or sub 1 right here just to confirm both are the same, and you can see it visually. It wouldn't matter either which way. You don't have to reference the empty cars $sign because you're inside of empty cars. It assumes that this is a variable inside of this data frame. So now we just have the 4-cylinder cars. So how could I look at just the those miles per gallons? How could I look at just those miles per gallons of just the MT cars subset? I want to look at just the miles per gallon of the MT cars subset. I want to look at just the miles per gallons of the MT cars subset. So now we're going to look at just this subset only, the miles per gallon. What could we do there? Great job, John, right there. You got it. Sub $sign. Oh, you know what? I haven't been on Top Chat. I don't know if I've been doing that all day. Now it's going to be quicker. Great job, John. And there's the miles per gallons. If we want to take the median, which our question, we could do mean or median. Doesn't really matter. There's the median for that subset. And watch this. There's 6-cylinder cars. And there's 8-cylinder cars. Does that make sense? Now, this is what our loop is going to do for us. So if I'm changing this value right here, I should probably put a what in its place. If I'm changing this value right here, I'm probably going to put a what in its place because I want to change it. So I should probably put a what in its place because I just want to run my loop and change that each time it runs. So that's what's going to change as my loop runs. I should probably put a what in its place. A placeholder. So we're just going to call this cylinder right here. Cylinder, or we call it capital CYL. Cylinder. Sure, that's how you spell it, I think. We're just calling it cylinder right here. And cylinder, cylinder will go through the values of, well, we don't want to store, it'll go through the values of 4, 6, 8. Because remember, those are the unique values of cylinder right there. So this is our vector. And we could just say 4, 6, 8 as a vector, or we could actually use that. And then this right here is our skeleton. So let's put a little skeleton on it. And then we probably want to store this. We could print it. We could store it. Let's store this into median dot miles per gallon. Median miles per gallon. Store a blank vector. And whoa. Hit a wrong button there. There we go. There's the median miles per gallon. And now when we run this right here, let's store into median miles per gallon into spot cylinder. And as dot character. I'm just going to store it into the word for position 4. Okay. And that should run. Let's try this out. Let's store 4 into cylinder. And there it is right there. Let's store 6 into cylinder. And we can check our code. There it is right there. And let's store 8. It's storing into the word position 8, not the number position 8. Because if I did the number, it would have stored to the, it would have put it in position number 4. But if I store it to position word 4, it calls position 1 the number 4. So it's not position 4. Position 4 is number 1. So I could go here to my vector of the median miles per gallon, and I could go here and say what is in position 4, and it says that. Or I could just simply call it by its number, position 1. So that's the name position 4, because I'm naming the vector as by using a character as a number. That might be a little bit confusing right there, but you could just go in here. It's going to look very different if you do it this way. That's why I didn't want to do it this way. If you do it this way and remake your vector, you're going to get a lot of missingness in your vector. So when we run it right here with 4 and if you take a look, it's going to make a bunch of missingness. So that's more specific to the problem I'm doing, where I have to do it as a character so that I don't get the missingness right here. I get a vector that's going to store to that position number. I just stored to 8, so it's going to store position 8 right there. So now I've got my skeleton, I've got my vector, and what is my placeholder? So all I need is my placeholder right here. So what is my placeholder called right here? So I've got my vector, I've got my skeleton. Like all these lines right here are just skeleton code. Those won't change. It's the variable, right? So it's this right here. This is my variable. So now that we've identified the parts, and this is a really good culmination of knowledge, all we literally have to do, if you're doing question number 2, I think I have the skeleton, but I don't know how to populate the vector. So the vector is the values. I think you're going through day, right? So you'll go through Thursday, Friday, Saturday, Sunday. Now you could technically write those out, John. So if your skeleton's working, you should be able to run this question with like Thursday, Friday, Saturday, Sunday. So that'll be the, if you go to levels of, it's like levels of the, levels of tips $ weekday, I think it is. Levels of tips $ weekday, right? Yeah, tips. Levels of tips $ weekday. Levels, tips, $ weekday. Does that work, John? To go more specific to that question. Levels of tips $ weekday should get you the unique levels of it. And that's what you're looping through is the levels. It'll tell you the levels of it. So that's a hint for the question you're working on. This right here, we just take the variable, drop in the variable. We take the vector we identified that we're going through. We drop in our skeleton right here, skeleton code right there. We reformat by holding Control-Shift-A. We run our code, and we take a look, and we have now created the vector. I'm going to reinitiate it so that way I get from the start, because I don't like the way it looks. And then I'm going to print it to the screen to finish off, and there it is. It does work. Can you repeat what happens if we didn't change named position to character? If you didn't do it as a character name, it's going to put it in that number position. That's more unique to my problem right here, so that's why I kind of glossed over it a little bit, because mine has that unique scenario where I want to write to it as a number. So does that make sense right here, Meet? I want to write it as a character, I meant to say. If you don't write it as a character, you store into position number 4, where previously I stored into position name 4. So this is when I stored into position number 4, it does this. This is when I store into position name 4. The named position is named 4, but it's position 1. But I stored it as a character, which makes it a named position instead of number. So when you don't use the as character, it says store to number 4 position. So everything becomes NA for missingness before. Yeah, so really good stuff right there. At least seeing that little bit of interesting nuance at the end of it. But really good stuff. A good 30 minutes of talking through this assignment. Lots of help here. This is not the easiest assignment. Great job, Meath, right there, and John. Not the easiest assignment, but great work, everybody, on all this practice. Let's head back and do some 201. Let people know we're working away and we're practicing, understanding how to code better. That's what we like right here. Rain, no rain question. Oh my gosh, where was that? I need to check the time on that. I didn't put the timestamp. Check time. Okay. You got it. Nice job, John. 100 points. Good questions. Good work. Great job, Meath, right there. That's huge. Yep. And then check your thing at the end to make sure it's working. Those are some tricky questions. Is this the quiz? Access denied. No. The quiz says I don't have access. So we gotta log back into my Pearson. My Pearson says no access to me. That is absolutely amazing. No access. Oh, thank you, John. John and Meath, you're so nice. It's really, students are so kind to me with their words, but it's really the hard work that you're putting in. It's hashtag showing up right here. If my students don't show up, I can't do anything. Like, imagine if I tried to teach and nobody came to class and nobody came to office hours. It'd be really tough. It'd be way more tough. You wouldn't get anything done. So if you're here, if you're watching, if you're working hard, and there's a lot of people who life, children, work, a lot of responsibilities can happen that interfere with our ability to do a lot of work. But if you're here doing work, hashtag show up right here. Jackson knows right there, 100 points. I'm not just trying to be all like, it's you guys, but it really is. It really is. I'm just going to say it again. It is you guys. Guys and gals and pals. Let's see right here. I'm going to drink more coffee. I'm on that 3 cup of coffee routine nowadays. We're finding the rain, no rain question right here as we listen to some really interstellar music. Got some foxes in the chat. One of my friend's grandpa said, he said, hi, I'm Fox. I'm like Rabbit. No, he said, hi, I'm Fox like Rabbit. And his name was, I'm trying to think of Fox's first name. He's got a granddaughter who's widely known, married to someone else now. Fox. Can you guess who his granddaughter is? Aha. Here we go with the accuracy of rain, no rain. Go check it out. The rain, no rain question right here. Now, this is a pretty tricky one. With the rain, and we need to take the timestamp. Boop. Timestamp time. 50, 36, 4 to 3. Here we are. So on the rain, no rain question, you need to first understand what's going on with this data table. This data table is showing us what happened and what was forecasted. So let's take a look at it over here on a smaller screen. Now, you're going to wake up in the morning and you're going to hear the forecast for the day. The forecast will tell you that it's either going to what or what. The forecast will tell you that it's either going to what or what. So just go with this right here. The forecast will either tell you it's going to what or what. It's either going to rain or not rain. Blake, you got it right there. And Bracey, great job right there. It's either going to rain or not rain. You say, you wake up and they're like,
Today it'll rain.
Today it'll rain.
I don't have an announcer voice. I got to be like, today it'll rain. So they're telling you this right here. Now, later in the day, you're going to see what actually happens. Like by the time you go to bed, you're going to know what actually occurred on that day. So you've got what was forecasted for you and what actually happens. So these are 2 categories. Did you wake up and you hear there was rain? Well, then rain was forecasted when you're told it will rain today. But there's some times where what happens? I'm telling you, you woke up and you heard it's going to rain today. But what happened? So you woke up and heard it's going to rain. But then what actually happened? You woke up and heard it's going to rain today. And you're like, oh, it's going to rain today. And then what actually happened on those 64 days? It didn't rain. Does that make sense how this is read right here? Like if you go left to right, you're looking at what did they forecast. To test our knowledge, we'll do one more right here. I want you to tell me about your day if you are right here. I want you to tell me about your day. Now, there were 7 days of the year that you had this sort of day. That's what the 7 represents. 7 times during the year, this happened. And this is a sad day maybe. So tell me about your day. Oh man, Brian, I woke up on this day. There was 7 different days this happened, but I woke up, blah, 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 blah. I heard blah, 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 and then blah, 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 blah. So what happened on your day? Forecast said no rain, and then it rained, right? You were told it was not going to rain on that day, and great job right there. You can see the forecast right here as we go across, and then you can see what actually happened. The actual is like what actually happens. The yellow right there is like you wake up and you hear, it will not rain today. And you're like, oh, it's not going to rain. And then later on in the day, it does rain. This happens 7 times throughout the year to you. So if you look at this, what would you say to me about these red ones right here versus these green ones? The red ones are when the forecast was what to what actually happened. The red ones, you might be able to tell if I do a little green markation right here showing you that. The forecast is wrong. The red, it's like they said it was going to rain, it didn't rain. They said it was not going to rain, it did rain. So the forecast is wrong for the red occurrences. For 64 days, they said it would rain and it didn't rain. So it actually did not rain. Even though the forecast is like, it will rain today. On those 64 days throughout the year where that happened, the forecast was wrong. Notice the forecast is right more often than wrong. Got to be hard being a meteorologist. But we understand how to read this data. On what percent of days did it actually rain? Now be careful. This is where we need to think about some marginal totals. On what percent of days did it actually rain? There's 365 days in the year. All numbers will be divided by 365. Let me ask you this first. How many days did it actually rain? We'll go back and look at the table. how many days did it actually rain? There's 365 days a year. Well, no, we're looking at actually bring some good answers there. How many days did it actually rain? How many days did it actually rain? Well, but think about this. We're just looking at actual rain, right? So how many days did it actually rain? Be careful. I'll show you the answer in a moment. I just wanted to be like, oh, when you have those moments where like, oh, that's how you read this. You suddenly see it. Not quite 25. 32. Great job, Blake, right there. Does that make sense if I show it that way visually right there? That it's those days. But sometimes the forecast is right, sometimes it's wrong, right? It actually rained on those days, 25 plus 7, and then the margin down here. So it'd be great if they gave you the margin, right? So that'd be the marginal distribution there, or the marginal number. And so that is the margin down there. It rained 32 days. It actually rained 32 days. So let me know if you have questions. We're just showing how to solve this right here and understanding the data. So 32 divided by 365. There's the number right there. We're going to copy. We're going to paste. We're going to move our decimals. Boop. There we go. On what percent of days was rain predicted? So what numbers do we need to add up here to say what percent of days was rain predicted? What percent of days was rain predicted would be how? Now, predicted means forecasted. So they should just write forecasted. What percent of days? Great job right there. Yep. Can't hear me. I'm going to sneeze. I was going to sneeze. I was like, oh. So 89. And we're dividing by 365 for 365 days in the year. It's apparently not a leap year. And then we're going to copy paste right there. So rain was forecasted way more often. 24.4. There we go. On what percent of days was the forecast correct? Now, this is sometimes called the on diagonal. So we showed this earlier. The forecast being correct means they lined up right here. So what is the... Can anyone show me the mathematics for this? Because it's out of 365. So what are we going to do right here to find out what percent of days was the forecast correct? Great job, Bracy, right there. Hope this question is making a lot more sense right here. And thank you for coming to office hours where we can practice, understand how to read this, and learn how to look at data. So basically 80%ish. Hey, you're welcome, Blake. Anytime. We're probably going to try to go for a good bit today. I know we're supposed to end at like 30 minutes from now, but we'll try to do even more. We'll try to get as much as we can in these videos. What bar chart? So this one's a bit weird at the end right here. If you look at that number we just calculated, can we use that one? No, we can't. Okay, so this one, I'm pretty sure the answer is right here because given it rained, the forecast was correct. So that's what that reads right there. It's odd to read this one. The Pareto, yeah, let me know which one, Taylor, and we can do a Pareto question. So this reads, given it rained, the forecast was correct. Can anyone show me the mathematics here? This is a tougher question, but I'm asking you, given it rained, see, even I went the wrong way right there. Given it rained, given that it actually rained, the forecast was correct. What is the mathematics to get this number right here? Oh, the Canvas content. We can do Canvas content coming up. Yeah, Taylor. We'll find the Pareto one. We'll do that here. Given it rained, and I'll show you visually. Given it rained, what is the probability the forecast was correct? So what's the mathematics for that? How did they get 78.1 right there? That reads, given that it actually rained, the forecast was correct. So what's the math for that? To get 78.1. We'll solve it here in a second. We should get 78.1 when we solve the math. Here's a hint. Given it rained, the probability of the forecast was correct. Great job, Blake, right there. Yep, that's going to solve for that. So given it rained, it's just weird, that graphic. And there's the 78.1 confirming we have the answer. Given that it rained, the probability of the forecast was correct. So that's actually a conditional right there. That 78.1 is a conditional probability. And then this is given it rained, the forecast was incorrect. And then they do it for the other one over here. Given that it did not rain, the probability of the forecast was correct right in here. So that's how they're solving those probabilities right there. Is there any evidence? If you look right here, these values are pretty similar. So whether it rained or did not rain, the probability is very similar. No, because the accuracy rates for the forecast, different types of weather, are very close. This one would show a difference right here, but these numbers are basically 2% off, so they're very close. Got 100. That's how we like to roll right here, 100 points in the chat. Okay, I think we got a few more questions. Let me take we'll do Canvas content coming up here in a little bit. Stat 201, Canvas content. Number 1. So many Moonbox W's in the chat. Fish and prostate question from the homework. Let's head over to the main screen. Fish and prostate question from the homework. I don't know this one. This one's like a new one. We have so many new questions this semester that it's like, I gotta know my stuff. Ryan's gotta. Oh, there it is. I thought I just saw it. Where is it? Fish and prostate cancer revisited. Wow, it's actually the name of the question. Okay, got some Swedish fish right here, men. Okay, so the fish and prostate cancer question. Let's head over to the main screen. Okay, we got the fish and prostate cancer revisited question right here. So with this question, medical researchers found from 6,272 Swedish men for 30 years to see whether there was any association between the amount of fish and their diet and prostate cancer. A mosaic plot of the results is given. From the mosaic plot, about what percent of all men in the survey were diagnosed with prostate cancer? Okay, so we need from all men were diagnosed with prostate cancer. Oof. So okay, look, they're showing you need to look at the what distribution right here. You need to look at the what distribution. What do we call this over here on the end of it? We call it the what distribution. It's the distribution in the what. Man, they want you to give you number ranges. What do we call it? The marginal, exactly. So, man, they better give a nice range for that. Type a whole number. So, this little mean, what I'm going to do right here, is I'm going to take this graphic. I would guess about 10%. I would guess about 10%. But I'm going to go more careful than that. We're going to bring over here to Word. We'll see if 10% would be right. That looks about 10-ish% to me. So let's figure out. Let's go right here and do the following. Okay. Then let's see what that is of the total. There we go. So then let's go here. Whoa, it's going to be less than 10%. Yeah, it's less than 10%. I want to see what range of values it accepts. And if it tells me I'm wrong by doing it this exact, we're going to be unhappy. We don't get questions wrong right here. We use every trick in the book we got. Looks more like 8-ish%. Oh, there we go. Look, it's going to be very close to a very... Okay. So that is a what right there. Let's find out. 8%. 8% is probably right. So that's a... How many segments have we created in this? So is that 7.5 or that... No, that's my brains. It's a 15th. So it's about 7%. So we'll see what range. 8% is probably going to give it to you. It better like 7% because that's going to be a 15th right there as best I can tell. So 7% should be acceptable. I wonder what range of values it gives. I hope it would accept at least 10%. So about 7%. Check answer says good job. I'm going to restart that question though. I don't think it's going to shift it. Let me restart that question right here to see what range of values it accepts. Because I'm very interested what it would take as a right answer. Okay, so it should do the same. Okay, it does look the same right there. Hopefully I didn't change it any. Let's put in something too high, like 14%. That's definitely not 14%. Holy wow. Okay, I got that's a little bit too nice on this question. 14%. All that time we spent taking a guess on it, it probably allows like 5 to 15%. 20%? No way. Did you put 20% and it took... Oh, wait. We could restart the question, but... Yeah, like, what's it going to accept? Like, you put in 100%, it's like, hey, good guess. We'll go crazy at 25. Yeah, that's not... 20% is way too high. We'll go 20%. It says no. Maybe 14% was the maximum. Oh, it accepts 15. So it's really, really generous on that. So that's nice. We went way too I know, right? It's... Oh, should have put in the wrong answers. I think it'll show us the plus or minus. But what about 1.29? See, now I want to know. I want to know if it accepts that like very low answer, because that's a little bit. I really did a lot of effort to get that answer. 1, no. Here, 2, no. Let's see what it accepts range of answers. Correct answer is 7. So we actually got the right answer. Oh, darn it. And I should have clicked it. But it looks like it's giving a range of possible answers. And so our 7% was basically what it wanted. Do realize we went really exact on this by looking at the marginal distribution right there. So I should have clicked and saw what it would accept. But that's how we figured it out to get exactly that. There are more men who are never seldom ate fish. Okay, so now we need to look at the other distribution over here. I know, right? It is comforting to know it's not like a very exact answer, because I was like, how exact does it want us to be? My 10% guess would have been right, though, from the start, and then I should have guessed that's smaller than 10%. We're asking about never/seldom. Okay, never/seldom. Oh, what percent of men are never seldom? A lot or a little? They're actually the whattest group of men. When it comes to never and seldom eating fish, that is the whattest group of fish eating habit. So you can see these are the men who have a large part, moderate part, small part, never seldom. It's the smallest. So there are more men who and never seldom ate fish. Okay. It's asking a bivariate thing right here. There are more men who. Okay. Such a weird way of asking it. Oh, man. Like, it's did not brace you. Let me see, though. So, what it's asking you to do right here, and it'd be easier if it wasn't the never seldom group. No, it's a decent question. Ban this question. I love Mewbots against this question. Think of this as a pizza. And if I told you you're really hungry, would you rather have pizza slice? Would you rather have pizza slice 1? It's a sheet pizza slice 1 or 2? This is an easy question right here to answer. Would you rather have pizza slice 1 or 2? You're really hungry. This is a sheet pizza. You'd rather have pizza slice 1. Does that make sense? So that's the total amount relative to 100% of individuals. Now, this is a harder one to answer. This is why I'm a little bit worried. Now, it's very hard to see here, but they're asking you, you're really hungry, and would you rather have pizza slice 1, which is that, or pizza slice 2? Now, I do think you're right. So which of those is bigger, pizza slice 1 or pizza slice 2? It's a close-ish call, but I do think it's so you're looking at the total amount of area on it. Does that make sense? I still think it's pizza slice 1. I wish they gave the contingency table to see the numbers. I think it's pizza slice 1, because pizza slice 1 is super long. It's like this really long, like they're both about the same thickness almost. This one might be double as thick, but that one's like 14 times longer or 15 times longer. So I think it's still pizza slice 1 is the bigger one. It's easy to tell up here that this is a bigger region than this one. So it's going to be the not prostate cancer. There are more men who did not have prostate cancer. So it's just talking about that right there visually. This is more gray area than this. It's not doing a bivariate yet. Does that make sense? It'd be easier if it asked us about the large part. Like there's more men who did not have cancer who had a large part than there were who did have prostate cancer. Like of the large part, more men did not get cancer than those who got cancer. Does that make sense as a statement? Of people who had a large part of fish as their diet, there were more men who did not get prostate cancer. Look at this bigger pizza slice right here than men who did get prostate cancer. That'd be easier. It's hard to tell with that one though. Like that little ban this question on that one. The percent of men, the percent of men was blank who never seldom ate fish is higher. The way these are worded. Okay. Which is higher, the percent of men with cancer who never seldom ate fish, or the percent of men who never seldom ate fish? Wait. Which is higher, the percent of men with cancer who never seldom ate fish, or the percent of men without cancer? Okay. Okay, never seldom. It's got to be the smallest group, right? It's the with cancer. Yeah, because right here we're looking at this is a larger margin right here. So it's talking conditionally. It's comparing the conditionals here, and I'll show it visually. Great job, Bracy. Bracy's just a rock star at this question. Bracy, 500 points. It's just those knots. It's talking about the widths of these right here. So it's saying that this width right here is smaller than this width over here. So it's the width cancer right there. Bracy, great job. It's comparing those. And to say the percent of men who never ate fish, never slash seldom ate fish, has a higher percent of cancer. It's only a little bit. This is so small, I wouldn't think there's much going on right here. So width cancer is higher. Great job right there. Just word on getting one wrong. Bracy, excellent work. Good practice. Had a lot to... Oh, wait, thank you. Oh, well, thank you. No, you're doing great. It's just reading the data, interpreting it, and then sometimes the questions can be really wordy. And it's just that there's a slightly higher percentage of men who had cancer who never seldom ate fish. So that's got right there. I would reverse that to look at the fish consumption and then the percent cancer. Like I'd reverse the graphic. I think that's part of the issue with that question. Great job right there. We got another another My Pearson studies students in an introductory class. Let's go check that out. We got the students in an introductory class right here. It's our class. This is our time here. Students in an introductory class. Chapter 3 quiz. Students in an introductory. Here we go. It's political views. Students in an introductory class. Let's check it out. Okay, we got the students in an introductory statistics class at 57-4-3 right here. And we can see they were asked their political leanings and they were asked their gender. So let's take a look at the question and break it down. It says, what percent of the class is male? That is called a what distribution. If we have what percent of the class is male, that is known as a what distribution. Because it's just like asking one variable. This is known as the distribution in the what of the table. So that is known as the what distribution of this. What percent of the class is male? I love this. Is a great question right here. We're not going to ban this question. What percent of the class is male is known as a what kind of distribution? Do you have that question, but it has the graphs? Oh, we'll do that. We'll do a second version of it here soon. Great job. So we'll do that next, Bracy. You got 100 points. We'll do the graph version of this next. Sounds like there's two versions of this. So what percent of the class is male is a what distribution? And the answer would be found mathematically by doing this, but we call it a what distribution. So what do we call this distribution over here? Because it's just one variable we're looking at. We're only looking at the variable in the what right there. So I'm not looking at anything else. I'm not looking at political leanings. I'm just looking at the this of the table. We call it the what distribution. Because we're not looking at any sort of part of the table of it. We're just looking at one margin. So we call that let's see if you'll get it for some points here. This is called the what distribution. So that's the percent of the class that is male. That is known as the what distribution. That is the marginal distribution, the marginal. So that's the percent of class that is male. What percent of the class considers themselves to be conservative? That's going to be another marginal distribution. Remember, marginal distribution is going to be the distribution in the margin. So when we go down here to the conservative, you go right here, and then we figure out of the total. So we need to figure out of the total what percent consider themselves conservative. So we go here to 33 divided by 205. And that is the percent that consider themselves conservative. And so there we go. We move the decimal, and that is a marginal distribution, marginal in the margins. Next, we go to here, what percent of males? Now we're talking conditional because we're putting a condition on this. What percent of the males in the class consider themselves to be conservative? So now we need to go and find out of the males, what percent are conservative? Now, who here can show me the math to do this? For of the males, what percent consider themselves conservative? Of the males, what percent of them consider themselves conservative? I don't keep saying alternative. Of the males, what percent of them consider themselves conservative? of the males, what percent consider themselves conservative? For the males only. So for the males, correct. I was actually looking at the wrong number. Great job. Great job, Bracy, right there. I was looking at the female total for some reason, but that is correct. And that is what we call a conditional distribution. So for only that group right there, so that's conditional on someone being that group. And there we go right there, 19.5. What percent of all students in the class are male who consider themselves to be conservative? So this says out of all students, this is like a cell percentage right here. So this is going to be a slightly different calculation. What percent of all students are male and conservative? So what would be the math here to say from all students, what percent are male and conservative? So for all students. So for all students, what percent are male and conservative? Not given someone is male. See, it says what percent of the males are conservative, but this is for all students. Great job right there. Yep. So now it's for all students right there, 23 out of 205. Be careful. You have to make sure you're doing like conditional if it says it, like of this group or of that. And 11.2. I think we've done it. It's easy to make a math error. I thought we would have made one, but we didn't. Here we go. Here's the other one. So now it wants us to find the what distributions for males and females. So now it wants us to find the what distributions for males and females right here. The first thing we're finding is the what distributions for males and females. The conditionals. So we'll need to take all these numbers right here and divide it by the total for each group. So we need to go 40 divided by 85. And, well, let me see. I can make this smaller right here so you can see the work as we do it. There it is right there. And let's make it a little prettier on the screen right here. We like it to be nice and pretty. I don't like that it does the question over to the side anymore because I don't need those. Oh, I can do this. Haha. User. I could be smarter and make it easier for you to see. And then I want to put this over here, and then I can be here in the corner. There we go. There's some screen organization. And so now we're going to times this by 100 over here, or we'll show the math again. There are 40 liberal females divided by 85 times 100. Copy over 1 decimal, round to 1 decimal. And then there were 35 moderate females times by 100. Move the decimal. There are 10 conservative times by 100. Move the decimal. And then for males, there are 51 divided by 114. We're just doing the conditional right here. 51 out of 114 times by 100. Move the decimal. I love math questions. Just don't make a math error. 40 divided by 114 times by 100. Move the decimal. Please tell me if I make an error. And then we're almost there. We just have conservative males. 23 divided by 100. Move the decimal. And times 100 rather. And there we go. Should be correct. You might get more than 100% just because some decimals round up sometimes. But this is the numbers right here. And now we have to make a graphic of this. Now, when you think about the graphic right here, this can help us see if there is or is not a relationship between gender and political party. When you think about it, males were more likely to be what than females? So look at my numbers and look at the data and say males were more likely to be this than females. Males were more likely to be this than females. Just look at the data with the numbers and say, oh, males were a little bit more likely to be this than females. Just look at the data right there. Percentage-wise, males were a little bit more likely to be what than females? If you look at the numbers. Conservative, right? So you can see conservative males about twice as likely as females. So we go down here to the graphics and we have males and females. And which graphic looks like it? A, B, C, or D, where males were about twice as likely to be conservative to females. And you have to be careful. You might be between two answers right here. I'll tell you how to narrow it down between the two. Which of these shows males were more likely to be conservative? You could narrow it down to two answers right here. One of them is wrong, but you should be between two answers right here. And let me see, A and C. I don't think it's gonna be A and C. Let's see here. So you might be able to do it this way. I think we gotta be careful. Let's double check. It could be A or C. I'm gonna go to D, Bracy. I think it's D. And tell me which graphic you think it is. And I'll tell you why I think it's D. If you look at D right here, look at the percent of females who are conservative. That's about what percent? Here's a hint. Look up here. if you look at the percent of females who are conservative, it looks to be about what percent? Just like looking at it visually, you'd say, oh, that percent of females who are conservative looks to be about what percent right here? And this is a hard part of this question, I'd say. That looks to be about what? Or the easy one is to look at males who are conservative looks to be about what? Males who are conservative looks to be around what? So conservative males, which is the blue right here, conservative males looks to be about what percent? $20, yep. And look right here. There it is right there. Now, if you were to look at, excuse me, if you were to look at liberal males, excuse me, liberal males looks to be around what percent? Liberal males, oh yeah, Taylor, we'll do that here in a second. I think that's our next thing on the list. You got it, Taylor? Liberal males looks to be around what? 45, and there should be a little bit what liberal females. Liberal males should be around 45, but there should be a little more what females. Liberal males should be around 45%, so liberal males should be around 45, and then liberal females should be a little bit more, right? So liberal males is around 45, and liberal females is a little bit more. So this helps confirm these numbers look accurate. Does that make sense? Like, this is just displaying for us the numbers we found right here. You see how there's the three groups. We're kind of comparing males to females, and then we got 47, 41, 12, 47, 41, 12, and then we got 45, 35, 20, 45, 35, 20. So that should be about 35 right there. And that does look to be about 35 in between the 30 and 40. So that helps confirm that we have the right numbers. It told me the answer was A. Ooh, really? Let me see. Yours might be different. It's saying this is the answer right here. So males, right? It can't be A because conservative males, this would say right here, 70% of males are conservative. Yours might be in a different order. So yours might have a completely different order, Bracy. But because this would say for conservatives, 70% of them are male. And this is going conditional on conservatives. Like, of the conservatives, 70% are male. So we didn't break it down that way by doing conditional on conservative. I think that might be a reverse of it. That's the graph it told me on yours. The way it shows it, I could take a look, Bracy. Like, send me it. The questions are normally different. I was working through the quiz last night and it told me the problem was working on. Yeah, and it was putting in what Brian gave. Yeah, so the quizzes do change. So make sure, or maybe there's another version of this one too. But the way this one, I'll see if there's another version here, and then we're going to do the Canvas content. Do the variables appear to be independent? They're slightly different for at least one group. So I would say they do not appear to be independent. It switched the numbers on me. Yep, it'll switch numbers. It'll change it. So that's why you're seeing me work like one version, and they have to see if your version's the same or understand the small differences. Males are slightly more likely to be what? I would say here from this analysis, males are slightly more likely to be what? From this analysis, males are slightly more likely to be what? That's why I'm saying they do not appear to be independent. There seems to be some sort of a relationship here where males seem slightly more likely to be what? They're a little bit less likely to be the other groups, but they're about doubly more likely to be what, according to this analysis? Males, right here, are more likely to be what? Males are more likely to be what? Males are more likely to be what? And there might be a third version of it. Males are more likely to be conservative. Great job, Jackson, right there. So males were more likely to be conservative. There might be a third version. We'll see if there's a third version. Then we're going to do Canvas. Up. I think we found it. Third version found. You ready? So produce a graphic of the display below. So this right here, I think, is the version you might have had. Produce a graphic comparing the conditional distribution of males and females among the three categories. So with this right here, we got to be careful because it's showing us a lot of graphics very quickly. 10 because they could be doing the conservative right here. So let me see, because this is the one I think you're saying where you're going to do it over here like this. So because it has to add to 100% if you're doing the conditionals. So it's either going to be that graphic or it might be this one here. It's this one. Okay, so you're saying it's going to be this one right here, I believe. Produce a graphic comparing the conditional distribution of males and females among the three categories. Okay, so they're saying produce something comparing males and females over the 3 categories of politics. So it wants to see if someone is male, here's the probability. So we need to go right here, and I'll show you how this one's calculated. So of the conservatives, tell me the math here. You ready? Of the conservatives, what percent of them are male? Of the conservatives, what percent of them are male? Of the conservatives, what percent are male? Oh no! Sorry, Bracy. Yep, Bracy, email me if you want. Bracy, you've been here working the whole time. Email me. We'll change the graphic for you. I'll do a correction on that for you. You've been here the whole time, and I appreciate that. And I think you got it. Basically, I think they could be more specific, say use a conditional distribution for each one of the ideologies and compare males and females ratios. It seems to me you know what's going on. I think that's a little bit mean. Sometimes you're here and we say, hey, let's correct that for you right there because you've been answering them all and doing great. So we're going to correct that one. Let me know. We'll fix that one for you right there. So 23 out of 33 right there. And so when you do 23 out of 33, you get 70%. And take a look. Where's that right there? That looks a lot like what? So the blue bar right there is the males. And we see of the conservatives what? Like, what does that blue bar represent? So that's of the conservatives. What does that blue bar mean? Of the conservatives, that blue bar means about what? Because if you see right where it's at, of the conservatives, and that's what they're trying to display to you visually, of the conservatives, 70% are male. Of the conservatives, 30% are female. Now, a good way to know this also is if you're doing conditional distributions, these 2 bars would have to add up to what? Like, I can identify that this one's wrong. Great job, Bracy, right there. Because if I stack those bars on top of each other, they would have to add up to what? Because this is of the conservatives, blank percent are this and blank percent are this. So this is obviously a wrong answer. By looking at it visually, it have to add to 100%. Great job, Bracy, right there. So that one has to be wrong just visually speaking. And these other ones over here, if this is not a right answer here, it's got the wrong XY combination. But if you notice, the bars stack up differently, and this would be over 150%. So if we were to choose an answer, it would be this one over here, where the bars would stack up to 100%, but that's not the right answer because we're supposed to be splitting it over ideology. Comment briefly on what you see. Conservatives are way more likely to be, like the proportion of females and males for the blanks are significantly different from the other categories, yeah. So where conservatives are at, there we go. That's got it. Awesome work. I think we're going to be doing a little Canvas content to end right here. Keep those questions coming in. We'll probably be doing a lot more chapter 3 quiz tomorrow. So let's check this out. Excellent work, everybody. Great job. Chapter 3 quiz is a good one right there. Talking about how we see there's a relationship right there when there's differences among the bars. And we're going to finish off right here with some Canvas content to end the day. Canvas content. Oh my gosh. Canvas content coming right up right here. Previewing the Canvas content. Here we go. We'll do 2 versions of the Canvas content to end the day. And I know, Blake, do you have more questions? We could try to squeeze one in here. Let's go check out Canvas content. Okay, Canvas content. Number 1 right here. This is the practice because these could be test questions. The blank is the group of things we want to understand. Now, if you were to take a slice of cake, that would be your sample. But you don't want to understand that slice. You want to understand the whole cake. So the slice of cake is your sample. You try it to tell your mom how good her whole cake is. Like, you know, she might want to know how you think the slice of cake is. That's your sample. But then she's going to extrapolate that and make guesses on how good the whole cake is, known as the what. So you take that slice of cake right there. That's your sample of the cake. Now that is going to be just a small segment of it, a sample of it. But is a group of people or items we want to understand. The thing we want to understand is known as the what. So the larger group, we take a sample to understand the what. Well, the parameter is what we want to understand. That's how tasty the cake is. So the parameter is the thing we're measuring. So a parameter is often called like a parameter of interest. So the population is what we want to understand. The sample is what we take of the population. So we take a sample of the population. From a sample, we get an understanding of it called a statistic. That's the rating you give your mom of the cake. Now, you might give your mom a rating, your dad might give your mom a rating, your siblings might give your mom a rating. And from this, your mom will try to estimate the true rating of the cake, known as the parameter. So she wants to understand the cake, and her estimate of it is the statistic because she wants to know the truth of how it tastes. This is our estimate of how it tastes, and this is the truth for how it tastes. This is the sample of cake you eat. This is the whole cake she wants to understand. This is the ratings you give from your sample. This is the truth of the rating of the cake for the whole cake. So when you think about like elections are a good way to understand this. Usually people go out and take what's to understand election results. Usually people go out and take what's to understand election results. You go out and it's a 4-letter word, starts with a P, it's a sample, but you go out and take a what to get election ideas for what's going to go on in an election. We call it an election what? A poll. So a poll would be a sample, right? The sample is being used to understand what happens on election day, and election day is our population of interest. Now, when they ask you the question in the poll of who are you going to vote for, they are collecting a what on you. When they ask you a question on the poll and they say something like 55% of our polls said they would vote for this person, they've just told you a what right there. So when they say 55, great job on a statistic, right? So then they're telling you a statistic, like 55% of our sample from the poll told us they would vote for this candidate. Now they're trying to understand what happens on election day, which is the population. And so on election day, if 52% of people vote for that, we'd call that the what. If on election day, 52%, which is what we want to understand, vote for that person, we'd call that the what, which is the thing we were trying to understand with our sample, with our statistic. The thing we were trying to understand, not the group, but the characteristic of that group is the parameter. So on election day, if 52% vote, which is what we were trying to understand by taking our guess of it, that would be called the parameter of interest. So then we would know the truth of what happened. And our guess was 55% from the sample poll we took for what would happen with the group of people on election day. Does that make sense right here? The group we want to understand is the population of interest. What we want to understand about them is the parameter. We take a sample of that group and we get an estimate of the truth via a statistic. So try to think of ways to talk through this and examples to use. I used cookies example earlier, cake examples, and election examples to hopefully talk through some examples of how we use these terminologies with a sample, with a population, with a parameter, with a statistic. But try writing them down and practicing those terminologies. What type of variable is player ID? Now, this is a hint right here. Player ID is a what type of variable? Player ID is a what type of variable by player ID. Player ID. Player ID. Now, I see it's a number. You're welcome, Taylor. Player ID. So it looks quantitative, right? But what if I told you my player ID is 50 more than yours? It's going to be identifier. Because player ID isn't like an amount of how much your ID is. ID meaning identification number, or like what is your like tax ID or driver's license ID. So when something has an ID number, it's usually an identifier. What is a good way to know something is an identifier? Identifiers can never do what? Keyword ID right there. Yep. And what is it can't be used more than once, Jackson. Great job right there. Identifiers can't be used more than once. Exactly, Jackson. So an ID is something that never repeat. It can never repeat. And so it's a special kind of categorical variable that never repeats. And you might say, well, wait, they're numbers. Well, it's just like your group person this. You can see right here, this is an identifier. Now, a team could be from maybe the same country. Like, like there's the New York Jets, the New York Giants. I know New York's not a country, but maybe a team has like, I don't know. It seems to be possible that country has two different teams. Maybe possible. Probably better to use. Oh, it's player ID. So yeah, they could be on the same team. Yeah. So it's not team ID. So yeah, definitely team could repeat. It would just be another player on the same team. So that's not an identifier because team can repeat. Position, people play the same position in the sport. The club they're a part of, club could repeat. Height and weight are going to be quantitative because we can use actual numeric differences between them. Even if you see here that the number doesn't repeat, it's still a quantitative amount. So remember, to identify quantitative variables, it needs to be an actual number. You need to say like, my height is this, your height is this, and I guess that's in centimeters or something. Or oh, look at that, height and weight are reversed. Oh no. Definitely, I'll have to tell Terry, I'll be like, did you know the height and weight are reversed in this? That's a data entry error right there if I ever saw it. But Height and weight are actual real numbers, and we can take quantitative differences. A blank is calculated to make inferences about a population. So the thing we get, and this is a good question right here, that gives us inferences about a population is the what? Variable, parameter, sample, or statistic. So the blank is collected. I said calculated. Oops. A blank is collected. A blank is collected. Would that be variable, parameter, sample, or statistic? A blank is collected to make inferences about a population. So the first way I said it, Blake, it actually would be that. But the thing we collect, the thing we collect is a sample. We collect a sample and we calculate a statistic. So I almost misspoke and got it wrong. We would collect a sample. You're welcome. No worries. Great job, Taylor. Taylor, thank you for being here. You collect a sample and then you calculate a statistic. Like if you're trying to figure out the average GPA of UT students, you'd collect 100 students and they'd be your sample. And then the average from those hundreds would be your statistic. And now you'd want to understand the true GPA of all students being the population and the true GPA being the parameter of interest. The median, what is one big error you think people make when calculating the median, which this one's nice on us. A big error that people make when calculating the median is they don't find the what when calculating the median. A big error that people make when calculating the median is they don't find the what, or they don't put them in what. A big error people are going to make, this one's nice and easy because there's 5 numbers. The middle number's the median. You need to put them in order. Great job there, Bracy. Put the numbers in order. If you don't do that, your median might not turn right. Histograms are for quantitative data. Our favorite saying, right to the high, left to the low. Whatever way the monster man's tail goes. Is this left skewed, yes or no? Is that data right there left skewed, yes or no? What are your thoughts on that? That is true. There's our monster man. Right to the high, left to the low, whatever way the monster man's tail goes. Should get a 10 out of 10. Let's cross our fingers right here. We did a lot of versions earlier. 10 out of 10. We love it. So hopefully you got a 10 out of 10 on this Canvas content. Remember, swing by any of these office hours to ask about the Canvas content. Any last questions right here? Really good office hours. We got a lot of work done. We started with some 320, and then we went and did some additional work right here. Another Canvas content. But pretty busy day here. Good stuff. So we got some earlier chapter 3 quiz. Ugh. Get some more sleep, get some more food. Good work, everybody. With that, and people getting tons of points, people are already at that 0.55. Blake's already at that 0.6. Great job at the Stat Nation Galaxy, Brian tier. What do you think about all those tiers? There's a lot of tiers, and you're doing a great job. We're going to keep throwing a crazy amount of points. So keep hashtags showing up. I'll keep throwing up big points. There might be some big, like, I'll tell you this much day after test. I didn't have those questions. Which did you want a certain one, Taylor? You want to do one more? We'll do one more version of it. Love the Brian tier. There's a whole bunch of different tiers in the interim people. We're gonna do one more version before we end office hours here. So let me know. We'll do one more version right here. Let's do one more version of it. Write down these questions because any of them could be. Oh, that's where we got that 8 out of 10 because we messed up, made a mistake. I just want to make sure pie chart is categorical and Pareto is categorical. Histogram is quant and similarly for quant. Yep. Here you go. Here's the cheat sheet right here. There's the cheat sheet right there. The green means categorical. You are right, Taylor. We might even speed run this one. There's the cheat sheet. Histogram, box plot, stem and leaf, go up plot. All data needs context. You are right there. Great job, Taylor. All data needs context. All data does need context to understand it. You are right. So we have here the thing that puts variables into groups, categorical. The blank is the group of people or items we want to understand. A population is collected to make inferences. Sample. Pie chart, categorical, Pareto, categorical, histogram, quantitative, histogram, stem and leaf, quantitative, find the mean. Oh my gosh, find the mean. I got to average the numbers. They average to 25. It's a symmetric distribution, it looks like. Submit that quiz. Get that 10 out of 10. The distribution down here was symmetric because look at this. You see how the distance here is 5 and 5, and the difference here is 7 plus or minus 7. So it's a symmetric distribution around 25. So the values would average to 25 if you did it. Why is 0 a right answer? That is not a right answer. But good stuff right there. Especially if you see me working these questions, you can get extra practice. You're welcome, Taylor. Another 100 points for 10 out of 10s. Hashtag show up to here anytime, Taylor. Just say, hey, Brian, can you work it? Or let me know which ones you're working on. We'll try to do those specific ones. Awesome office hours. Thank you so much, Blake, right here. Thank you, everyone who's showing up. We just get haunted by that 8 out of 10 I made earlier where I didn't change something. Quantitative variables must be numeric. Yeah, they have to be numbers. A group of people we want to understand. Populations what we want to understand. Identifier, special case, categorical is true. Categorical. Make sure you understand these. Like, don't just put the answers in. Scoot to the left. True. Good stuff. Schmidt quiz. Got it. Sometimes when I'm talking through the answers, sometimes I'll change something. So I was like changing an answer, talking about it. You're welcome, Jackson. We're just going to get haunted by that 8 out of 10 I made earlier. I changed population. It was this one right here. I was talking through it in earlier office hours, and then I like didn't change it back because I was explaining what the things were, and then I was like, oops. And it was so funny. Who was it? Someone was saying like we got something wrong because the mean versus the median is impervious to or not impacted by outliers, and then we did get something wrong. Well, let's head over there, good. Awesome work, everybody. We're gonna put those timestamps in. Until then, great job. Keep up the great work. Bye for now, everyone. Bye. Office hours over.